Okay, so this is unit 5.5, factoring complex trinomials. If you recall, or if you remember, yes, if you recall, a simple trinomial is a trinomial where the a value in y equals ax squared plus bx plus c equals 1. So we've looked at quite a few of those, and sometimes the a value wasn't equal to 1, but we were able to factor that out so that we were left with a simple trinomial. Today we're going to take a look at what factoring complex trinomials looks like. So the first thing we're going to do is we're going to take a couple of expanding questions, and we're going to take a look and see what maybe some patterns are. Because what we want to be able to do is work backwards and factor. We want to be able to take a question that is in this form here. Oh, I forgot to turn my pen on. Okay, that's in this form here, and put it into a form that looks like this. So where you got two binomials being multiplied by each other. And remember, we want to do that so that we can figure out what the x-intercepts are of a graph. So let's just take a look at what happens when we expand here. So when I expand, we do 3x times x, that gives us 3x squared, and 3x times 7, and that's 21x, and then 2 times x, that's a 2x, and then 2 times 7, that's 14. Incidentally, that whole process that I just went through there, we call that foiling, and that seems to be weird. It has nothing to do with the word foil. It's actually an acronym for front. So you multiply the two front terms, the two terms at the front of each bracket, so that would be the F. And then you multiply the two outside terms, so 3x times 7, that would be the O for outside. Then you multiply the two terms on the inside of the expression, so that would be the I in FOIL. And then you multiply the last term in each of the bracket, that would be the L. So we call that foiling. Okay, now we've got 3x squared plus 21 and 2 is 23x plus 14. Okay, so now the next one I'm going to write down slightly differently, and then maybe we'll look at some patterns. So basically what we did is for the F and the O in FOIL, you're taking the first term in the first bracket and you're multiplying it by the second bracket. So basically you're doing 2x times 3x plus 4. And then for the I and the L in FOIL, you're taking the second term in the first bracket and multiplying it by the second bracket. So that would be minus 5 times 3x plus 4. And so when you expand all that, 2x times 3x is 6x squared. 2x times 4 is 8x. Minus 5 times 3x is minus 15x. And minus 5 times positive 4 is minus 20. And then bring those two middle terms together. You get 8x squared minus 7x and minus 20. So I'll let you do the rest of these. You can stop the video and then come back. Okay, so go ahead and do them, and I'll just quickly do them here as well. I wish I knew how to do video editing. I need one of you guys, I think, to show me how so I can fast forward through all this, or I can put music in all this and just make it all happen so much quicker. But I don't know how to do any of that stuff. Notice how here I wrote down the +1. That's kind of important for when we go to do the factoring part. All right, so there we go. So now we want to take a look at what patterns do you notice that can help you work backwards from the answer to the question. And sometimes seeing the patterns is kind of hard to do because there's certain patterns that I would want you to see. You can stop, take a look at these things, see what patterns you see in the numbers, what, when you're multiplying, adding, what the answer has to do with the original question, what the factored version has to do with the expanded version. There's all sorts of little patterns. But there's a couple of patterns that I want you to notice here. Now remember, if we're thinking about this working backwards, the main patterns that I want you to see is that you've got 2x squared and minus 12. Those two things multiply to give us negative 24. And then this 5x, if we're going backwards, it came from doing minus 3x plus 8x. And if you notice that minus 3 times positive 8 is also negative 24. And if we take a look at, let's say, look at this one, you got 6x squared and minus 3. Those two things multiply to give you negative 18. And then the 7x is broken up, if we're going backwards, it's broken up into, or it came from 9x minus 2x, and 9x and minus 2x also multiply to give you negative 18. Even if I jump back to, say, part B, 6x squared and minus 20, I'm not too worried about the x squared part, but the 6 and the minus 20, they multiply to give you minus 120. And then positive 8 and negative 15 also multiply to give you negative 120. And last, I'll just take a look at A. 3x squared and 14. So 3 times 14 is 42. And 21 times 2 is also 42. So that middle term that you have in the expanded version gets broken up, if we're working backwards, gets broken up into two numbers that multiply to give you the same value as the F and the the F and the L in FOIL. So the first term and the last term in the expanded version. So let's just take a look at this first question here. 6x squared minus 7x minus 20. Well, we actually have that question already up above, but I want to work through that then. So if we're working backwards, this time when you're playing the X game, you want to do 6 and minus 20. You don't want to just do the minus 20. With a simple trinomial, you're basically doing the same thing, except for the term out in front of the X is positive 1. So 1 times whatever that last term is would be your product. So 6 times negative 120 is, negative 20 is negative 120. So that's what the two numbers have to multiply to. They still have to add to give you negative 7. And those two numbers happen to be negative 15 and 8. You can go through your pairs of numbers. So 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and, 24, 6 and 20, 7, 8 and 15, and I think maybe 12 and 10, 10 and 12. I think those are the last ones. Okay, so the pair that's going to give you negative 7 is the 8 and the 15. So then you split that middle term up, y equals 6 squared, and we need the minus 15x, and then we need a plus 8x. Okay, so that middle term gets split up into those two values that you found. So this is a totally different process from simple trinomials. You can't just go right from the question to the answer. And this process is what we call decomposition. Okay, you're decomposing that middle term into two separate pieces and then working from there. Okay, so now the pattern. Let's take a look at part B, because it's the same question. So part B up here, the 6x squared and the minus 8x. To go backwards, remember it was 2x times 3x plus 4, and so that actually is 6x squared plus 8x common factored. So this is kind of factoring by grouping. So I'm going to factor these two, and I'm going to common factor these two. So that gives me a 3x and a 2x minus 5 plus 8x and minus 20. They both they both have a common factor of 4. And when you factor 4 out of them, which is, remember, factoring is basically just dividing, you are left with 2x minus 5. And notice, because of the way that I have my minus 15 and my 8x, I have a slightly different answer than what I had up in the other question. This had 3x plus 4 in the brackets, but this one doesn't. This one has 2x minus 5, but that doesn't mean we've done anything wrong. And how we know we've done it right is that these two brackets are the same. Had I put my 8x first and then my minus 15x, then I would have gotten what I got up here for this part B question up here. So common factoring this part and this part, they each have a 2x minus 5 in common. And then when you factor that out, you get a 3x plus 4. And you're done. Okay, so let's try another one. 2x squared and 12. So 2 and 12 multiply to give us 24. And they always have to add, whether it's simple trinomials or complex trinomials, they always have to add to give you the number in the middle there. Okay, so 24, 1 and 24, 2 and 12, 3 and 8. Well, that might be it. And in fact, I think it is, because the next one is 4 and 6, and that doesn't work. So it's 3 and 8. So y equals 2x squared. And again, it doesn't matter if you put the 3 first or you put the 8 first. It really makes no difference whatsoever for your final answer. So I'm just going to go 3x and 8x and 12. I'm also going to make this a little bigger here. Okay, so common factoring these two, they only have an x in common. And so we're left with 2x plus 3. Common factoring these two, they have a 4 in common, and that leaves us with 2x plus 3. Again, these two brackets are the same. So that's what's first in the next, and x plus 4, and we're done. Okay, I'll do one more. Now for this one, you can either leave it as minus 6x squared plus 13x plus 5, or you could, if you wanted to, factor out that negative sign. That is okay as well. That would be doing common factoring first, which is fine. You don't have to. I can show you how the answers look different doing it either way. So first, this time I'm going to just leave the minus 6 there. So minus 6 and positive 5. That's minus 30, and they have to add to give me 13, positive 13. So since they have to multiply to give you a negative, one has to be negative and one has to be positive. So you can check on your own, but this is going to end up being positive 15 and negative 2. So then y equals minus 6x. I'm going to make it bigger again. Minus 16, or sorry, minus 6. Let me erase that. So minus 6x squared plus 15x minus 2x plus 5. When you factor this, make sure when you common factor out that negative. You should always common factor out the negative. So that's a minus 3x, leaves us with a 2x minus 5. Because when you divide 15 by negative 3, that is a minus 5. And then for these two, they have nothing in common, but we're going to put a minus 1. Again, if this is a minus, then your common factor should be a minus. If that leading number is a negative that you're trying to common factor, then common factor out the negative. And that'll leave us with a 2x plus, sorry, not plus, 2x minus 5. Because when you divide positive 5 by negative 1, that gives you a minus 5. And so then we have 2x minus 5 and minus 3x minus 1. All right, so now what I want to do is show you what this would look like if you common factored that minus out of there first. So let me just do that. So if I take a negative out of all this, that leaves me with a 6x squared minus 13x minus 5. So now when you do your x game, they multiply to give you positive 30 and add to give you negative 13. Oh, sorry, no, they multiply to give you negative 30. So 6 and minus 5 is negative 30. And so then it's going to be the same numbers as top, except it's going to be minus 15 and positive 2. So same value, but different sign. So y equals minus 6x squared minus 15x plus 2x minus 5. Minus, I'm just going to put square brackets here. Again, this is going to be a 3x, and that's a 2x minus 5, and then plus 1, and 2x minus 5, and so y equals minus bracket, 2x minus 5 is still the same bracket as above, but you'll notice that the 3x and the 1 now are each positive, and that's because in some sense, what we've done is we've common factored this. Whoops, I don't want red. We've common factored this, taken a negative out of all of that, and you got 3x plus 1. And that negative sign went out in front of the whole thing. Okay, so they are the same question. They give you the same x and y or x-intercepts in the end. And let's just talk a little bit about the x-intercepts in this case, because that's part of the question here is factor each of the following and state the x-intercepts. Okay, so remember that fundamental theorem of math says that for the x-intercepts, we want this whole thing to equal 0. Because for the x-intercepts, we let y equal 0. And if that's going to happen, then either 2x minus 5 has to equal 0, or 3x plus 4 has to equal 0. So solving for 2x minus 5 equals 0. The minus 5 comes to the other side. It becomes positive. And then divide both sides by 2, and you get x equals 5 halves. Positive 5 halves. So notice that really just turned out to be this number divided by that number. So this is the constant. The minus 5 is the constant. I'll write that word up there. It's the constant. And then the 2, that's a coefficient, and it turned out to be constant over coefficient. And then the opposite sign of that. So for the next one, if you imagine, the 4 would go over to the other side, so that would be the opposite sign of the 4. And then you're going to divide by 3, so x equals negative 4/3. So you should be able to just go right to the answer. So for the next one here, if we let this equal 0 to get the x-intercepts, so for the first one, x would equal, imagine, the 3 goes to the other side, so that's a minus 3, and then over 2. And for the next one, that just is a -4. And then for this last one here, so 0 equals the negative of 2x minus 5 and 3x plus 1. So x equals, the 5 would go to the other side, it would become positive, and then over 2. And then for the next one, the positive 1 would go over to the other side, it would be negative, and then divide by 3. And you're going to get the same answer if you do that the same way. So you got minus 3x minus 1 equals 0. Bring the 1 over to the other side, it would be positive, but then you divide by -3, and x is going to be -1/3. So no, the answer in the end to find the x-intercepts, it still works the same. The factoring part, I would mark either one of them correct. Usually if we can get away with it, if we can get away with not having a negative sign at the front of a bracket, often that gets factored out. So I'll just do this last one here. Again, let's suppose we don't factor out that negative to start off with. So they multiply to give you -42, add to give you -1. You can think about it, stop the video. But those answers are -7 and +6. So y equals minus 2x squared minus 7x plus 6x plus 21. These two common factor to just give you an x, and that's a minus x. Make sure you take out that negative sign. So that'll be a +2. Let me just erase that. Okay, so we have to take out a -x, and that gives us a 2x plus 7. And on the next one, we're going to take out a +3, and that gives us a 2x plus 7 as well. And so that gives us 2x plus 7 and minus x plus 3. You can either leave that like that. I'm okay with that. You can factor that negative sign out. Or actually, before we do that, what you can do is you can just take these two terms, these two, because we just don't, it's just a form thing. It's not a right or wrong thing. It's just a form thing. So we could take this and just rearrange these two. So the 3 is positive and the x is minus. You can do that. That looks nicer than the other way. You also, if you wanted to, let's just go from this line to this line, factor a -1 out of this bracket. So I'm just going to take a negative out of that bracket. I'll leave the 2x plus 7 there. It doesn't. And when I divide each of those by a -1, that gives me an x minus 3. So all three of these are equivalent to each other. They all give you the same answer for the x-intercepts, and they are all correct. Okay, so none of this they're all fine. And I would accept any one of those three answers. Okay, I'm going to leave the rest for you to do for homework. Again, if you have any questions, please contact me.